All right, let's see if this thing starts up. It is 12:53 p.m. on Thursday, May 4th. I am doing some interaction system design for an interaction system that I'm trying to redefine in a way to be easier to use by other authors. We have a pre-existing design already that's fairly solid in, I would say, the most fundamental areas. However, it's unclear in, I would say, the middleware level or the mid-level where you're doing things like, instead of just being able to draw something to the screen, being able to sequence um, different modes of the interactive, where you had to remove pieces and add pieces back, scene management, level management, um, progression within a scene, triggering events, managing complex internal state. Those kind of things that go beyond your basic tutorial. We're lucky in that we already have worked on two different interactives for this code base. This is for an NSF grant. The third grant in the series of which is called iStep, which is, I think, what was it called? Let me look it up. There's just go to chat plus desktop. And this is iStep, the brief of it. It's called, it addresses a basic research question by exploring the role of the body in physical activity and learning through the design of a new genre of developmentally appropriate learning technologies for young children. There's increased recognition that the body plays a role in cognition. Human beings, especially young children, understand complex concepts in part by relating them to how we move our bodies. In extending these ideas, the iStep project also aims to develop teaching techniques and technological tools, that's where we come in, that can be used in real classrooms in the near future, instead of supporting the learning of individual students as many current technological advances attempt to do. The iStep project creates opportunities for entire classrooms of students to engage together and to model scientific phenomena using their bodies. Specifically, let's see, where's the part? The new stuff is, here, this is the new part. No, we're not doing haptic. The new part of the system is being able to control the simulation through gestures, like as they hold up their body in particular positions. The motion tracking system that the other team is working on will be able to determine like this entity in the space is holding this posture, and we can use that as an input into the simulation and have something happen. So that's new. And they're also doing something where you can have props in the space now. Currently we only track individual students, which are they're little kids, so they run around real fast. But the ability to use a prop that has a meaning, has some semantic meaning within the simulation, we'll be able to do some stuff with that. So right now we have a system that we have to author using our code tools, and our programmers have different levels of, well, there's just two of us basically, or three at sometimes. The tools themselves can be used by me and the other developer who's also the principal at the company that I'm working for. So, but the interactive concepts, some of the interactive concepts, I think could be cleaned up, because we want to be able to author these things very quickly. Right now we can't, because there's actually quite a lot to know about doing an interactive, making an interactive simulation, and some of those concepts are not, let's say, as deeply. It's like some of the interactive concepts aren't as It's not the main expertise of the researchers. The researchers are doing qualitative and quantitative analysis and doing all the statistical stuff and designing these studies, and they understand how they're learning scientists. But making a graphic move and like the available, um, the range of possibilities and how you mix those together, those are relatively outside of their realm of expertise. And so that's where like I come in, and that's where Ben comes in, who's the principal at the company. Um, so figuring out a common language or a common set of tools, which we attempted to do at the beginning of this project 3 or 4 years ago, um, that you can express interaction. We can, if there's some way that I can make a pass now before we really jump into the code, and create a few new subsystems that are easier to teach. I think one thing that helps now also is when we started 3 or 4 years ago, we didn't have the curriculum put together, and so now like the research teams have like 2 science units prepared. One is called States of Matter, which is about using water as the subject, exploring this transition of states between solid, liquid, gas, what that means on a micro level and a macro level, and also providing activities in the interactive space, which is like depending which classroom it is, it's either a 10 by 20 or a 10 by 10 space. Being able to act out what they think water or water particles are acting like. There's some disagreement on the best way of representing water so it's accurate. And then like, so like we're not I'm not a subject expert or a learning expert. So anyway, we now have units for that, but before when we were starting it, we didn't have any of that in place, but we have the units now that we can use as the basis for designing or redesigning, refactoring the interactive system. And we also have a better idea of what works in the classroom and what we have a pre-existing or an existing standard for how the interactives work that's understood by the researchers. So we have a place to start with. So this is a good time, I think, to revisit it. But I've been kind of spinning my wheels for the past day, trying to figure out what it is. How should I hit this? This is my sprint currently. So from April 26th to May 5th, which is tomorrow, I've been basically doing architecture, review of the current architecture modules, kind of thinking about how they work and how they might group. And then, this is where I am today, writing a description of how the system would work technically, what parts of the system we can reuse, and then to write a succinct description of the interactive experience. Tie it back to the interactive design objectives that are from the grant. And then review the past particle activity grid. This is like at the curriculum level. And make sure that we're accounting for all the interactions. So I'm basically collecting and categorizing, regrouping, reconcepting, naming, hierarchalizing stuff. And it's kind of one big cloud in my head right now. So what I'm going to try to do is linearize it into some thinking. But I think I actually need to get away from the computer to do that. I think that would be a good idea. Because right now, is this volume, is this even working? It seems really quiet. No, it is, I guess it's coming out. So I am going to take this camera and move it over there. So I don't think I need to use, which view should I use? I guess I can use this one. Yeah, I won't be able to read the chat stuff, but at least other people can see it. I'm trying to think if there's a way I can hear the audio from this. Actually, I think I'll jump into I'm making let me make a voice channel here. So if people want to ask a question, they can. And let me do it this way. So I should be able to make another voice channel, which is like, I used to have a live stream interaction. Let's call it live stream talk. And so anyone should be able to access this live stream talk. All right, so now am in this channel, and I guess I need to also set it so I can hear it. And that will go to the USB codec, I think. That's plugged into this. Boosted that. So if you are on the Discord, which you can get to at going to davidsay.com/virtual-coworking, you can see how to get into our co-working chat room. You can join that channel, the live stream talk that I'm in right now. Actually, I used to call it live stream, I think. Let me call it that. That might make Discord reintegrate.
Gotcha.
Yeah. I'm changing this. It's all right. Oh, hey, Courtney. Can you hear me? Is this pulling the... I guess I need to change this so it pulls the right microphone. Voice input device. I am on the MGXU test. I think that's working. So now this is pulling from the same microphone that's also going to the live stream. So I am going to move this camera over to the dining room table.
Yeah, see the problem with this is I'm getting you at different rates.
Yeah, you would have...
Either mute the...
What you can do is you can mute me in the voice channel, and you can just let's have the YouTube video on.
Oh, that's smart.
Yeah, so it'll be a little bit delayed still, but you won't have that double issue problem.
I could mute just an individual person.
Yeah, Discord rules. Discord has anticipated your needs. All right, so I'm setting up at the table here. I don't have the channel feeding into the YouTube video, though, I don't think. So people can't hear what you're saying. Maybe I should set that up. So if I'm in this, and I can set up a loop back, or I can I might not be able to change the setting right now. Audio input device 1. I guess I can set loop back. How would this work?
I can hear myself delayed.
Is that what you want? So, okay, so now I have the loop back set, and I need to set this output of this, or the input from this should be, instead of MGXU, it needs to be the aggregate input device. Let's see. You know what? Forget it. I'm not going to set this up. I will just let this input device will be the microphone. The output device will continue to be USB audio codec. So I can hear it on the main speakers. But this is not being recorded in the stream. It's too bad, though. I had to set it before. Actually, I would want to set this up to... No, that's right. I do have to set this up as loopback. Okay, let me just set this up really quick. So the loopback device is an audio device where you can... Let's see. So everything that's coming out from here, I'll monitor it through this. And I want to capture the application that's running, which is not showing up here. I want to capture the audio from Discord. Why isn't it showing up though? It should be right here. Safari, Chrome. It could be because Discord is actually a web browser running in a wrapper. So that means I need to do loopback. That should be fine. So Discord needs to be outputting through loopback. Right. And then, no, then the input device needs to be, no, this is confusing. No, this is, I don't, so this is Discord. So Discord's getting the voice setting, it's outputting to loopback. And then OBS is reading from loopback. And I'm monitoring. Is that right? Loopback is right. So Discord to loopback. Loopback is then the input for OBS. I think I've set that up as aux2. And aux2 is loopback. And then I'm also monitoring through the audio codec. So that should theoretically work. Courtney, can you say something for me as a test? It might take 15 seconds for her to hear this. I can also test it, I guess they're here. If I set this to loopback.
Yep, everything's good.
All right, okay.
How's David Say doing?
Okay, so I can see it coming in there. I think it's coming out on the stream.
Yep, everything's good.
Yep. All right, so we have two-way communications and it's being recorded in the stream. So again, if you want to join in this conversation, you would go to davidsay.com/virtual-coworking. Join the Discord chat. I'm not going to provide a link to click on because I don't want people garbage clicking the link. If you really want to participate in this, you're going to have to work for it. So that's the rule. So I'm switching over to the other screen. I'm bringing my work over there, and I'm going to try to get some interactive design moving. Okay, so I think everything is set here. So there's about a 15-second delay from between the video and what I'm doing here. Suppressing the urge to clean the office. Hopefully the audio's...
I'll just be a delayed laugh track.
Yeah, there's a little bit of audio coming through that. I'm surprised where it's coming through. All right, so let's see, where am I going to set this camera up? Is this cable long enough? All right. So I guess that's as good as it's going to get. I should have, let's see how this looks. I can't really see the camera from here. Make a little window here. They may see through this. I can see the computer from here. So if I sit here, I can kind of see this computer screen from there. have a fun real-time experiment. All right. Can't see the desk though. Now, we'll see how this works. So, let's just point this down. On this piece of paper, let me set a 15-minute timer so I can start the billing clock. 15 minutes. I have no idea what time it is. My phone is over there. I suppose I should put this in this phone. I'll grab the phone. It's 1:15, let's say. Hey, kitty. I had to take the cat to the vet today for an emergency lion cut because it was very matted and he had gotten a dried turd stuck on his butt, which was slowly shrinking and growing tight and pulling all the hair out of his ass. Well, that's what I thought was happening. Plus, it smelled terrible. So he's been sedated, and he was not in a good mood before. He seems to be feeling better now. So here, and I sort of fly. So I've been drawing these diagrams, and this is basically the user level, and there are two interactives. So now that I'm away from the computer, I'm forced to deal with the concepts that are in my head and create them from scratch. So let's think about what is an interactive in this case. Maybe the easiest thing to do would be to think of how you start the interactive. No, maybe not that far back. I'd started writing down this game loop. The one that's relevant for the particle game, states of matter, which it's module input, followed by update, by think and execute, and then repeat. And this happens both on a module level and on an individual piece level. So how would I express that? And why is that important? It's important because we have the notion of independently thinking pieces. That have properties that affect their behavior, or that affect, let's say, appearance. Also, position in space. What would you call it? It's not, I guess you could say animation, but properties that change over time. Let's call that, what would you call that? It's not AI, it's something else. It's time variant properties, or time varying properties. And then behaviors. So the independently thinking pieces only are aware of their inputs. They only act on local knowledge to themselves. And then these pieces are managed by player managers. Let's call those players. These are JavaScript modules that create pieces, assign properties based on or properties based on conditions. This is actually probably this is where the big choke point is. It's difficult to know what those conditions are. I guess the way it's assign properties based on, let's say instead of conditions, knowledge a piece doesn't have by itself. Piece does not already have or can get by itself. And so there is a condition with pieces. Pieces can't query the world. Is that true? That is true. That's for performance reasons. Pieces generally can't query world conditions or test for world conditions. Can't test. They can query world properties, but they can retrieve properties. And so everything in the simulation is a piece. Like the world is another conformative piece. So, no, the world is not. The world's a player. So actually that's an important interactive concept for the way of managing these things. And so one challenge is the players have to do quite a bit of coordination. And this needs to be broken down even further. Not only does a player have to create a piece and manage groups of pieces, it also needs to be able to provide, it needs to be accessible to pieces. Or does it? How do pieces get world data? That's a good question. How do pieces get world data? That's something that's not clear. There's various ways we've hacked around it. But there's no method for it, no clear hierarchy. How does it get world data without... And how do we represent world data? Right now we have a bunch of like players. There's no player hierarchy. There's no player... So since pieces generally do not have links back to their creator, because there could be multiple manipulators of a piece, the way the game loop is set up is so that during the update pass, everything that's doing an update gets a chance to update before moving on to the next phase. And there are 3 available phases for player modules. That is the think. Oh wait, is it think? It's think, overthink, and then execute. Is that right? So update, all update does, the update phase, the only thing you're allowed to do in update is to update the current state of yourself. For a piece that's moving, for example, if there's a piece that has a velocity of, let's say, 10 units per second. During its update cycle, it would get the next clock increment and then update its position if it's a self-moving piece. And if it collides with anything, then it would set a collision flag. So basically, all the conditions that have changed occur there, but the tests are not done there. The tests are done in the next phase, which would be think or overthink or execute. One thing that's presumed too in the physics-based engine, which we're not using right now, is the physics pass also runs right after update or right before update. It's not clear. It depends which physics engine you're using. And that creates lists of collisions and so forth that then can be checked. So the reason why think happens afterwards, think is when you're inspecting the conditions and what have changed. There's another question. What's our standard way, or what's a best practice for continuous values and events? Continuous value events, let's call that a condition met event. And these things have to feed into some sort of condition engine. So I think one starting point then would be, one starting point is to, I guess, just making a list. Make a list of player responsibilities. And actually now I need to go back to the computer and look at them. Kate, what are you doing? Looking doubtful. Let's see. There's actually people in here. Okay. So what I'm going to do is I'm switch back to the desktop. So I have a list of something I want to do here, which is to actually close all this stuff. I'm wearing the wrong glasses, aren't I? These are not my computer glasses, so that's why I can't see anything. Where are my computer glasses? Yoo-hoo. Here they are. Kitty. I don't think people have seen the... People want to see the shaved kitty? Hey, cat. Come here. Hey, sweetie. Poor kitty got a line cut. Hey. Yeah. Look, a little lion. He had a giant turd dried up stuck to his butt. And so I was like, had to bring him in for an emergency sanitary thing. And they gave him a line cut because he needed it. He was all matted. You can see all this dry skin.
She's
They
pretty.
couldn't get at it. Poor kitty. He's nice. He's soft and fuzzy now, though, which is cool. And he should be much more comfortable. All right, so let us take a look at the player code. Where is that? That's not it. It's this. This was the, you can't see what I'm doing, looking at. This is the raw outline of one of the players, which in this particular game was all in one file. So let me just start making a list of what's in here. Actually, I guess I can do this on the screen. Let me just pull up a notepad. And I think I could use this one. This is, I think I've already copied this as something. Let me just make sure. This is 1401 game particles. So is it actually this that I was looking at? No, this is major modules. 4-1 game particles. That might be this. App shell. Oh, this is not the game level. I did not copy this in. That would be here. All right, so this is just wasn't named. So this is system modules. These are game modules. So I do have that. Okay, so zoink. I'll go back to this. And let's do some quick breakdown. Now, this is starting off the top of the list. Particles. This is the bootstrap. And then it actually starts running here. These are the modules that are loaded. So let's call this module or player module responsibilities. I don't know if you can read that. I should probably make it bigger. Oops. So much beeping. That was 15 minutes. That felt like an hour. So another 15. What time did I start this? It's 1:15 about. Just updating my timesheet. 3:15. Resume architecture. Uh-oh. There we go. Resume architecture. So player responsibility modules would be to set up or select dependent library modules. What's a better way of putting it? That's a generic description. Select, what do you call these? These are libraries these are other modules that provide other system features. Okay, import system feature libraries, needed ones. I wonder if I can make this font bigger. Font bigger, just so people can read this. Of course, it's not working now. That shortcut is as big as it gets. Note font bigger. All right, that's a little bit better. Let me fix the accessibility too here. Accessibility preferences. More options, adjust size and location. Move this to this side. This is the zoom functionality that I can get at when I... So now, it resets every time I unplug the monitor. So now if I want to show you something, I can click on here and it'll get bigger. So that would be convenient. So we input the system, the things we need. It's probably worthwhile looking at the kind of functions that we have. Oh, maybe not. So what else does this need to do? It needs to define module global data storage or module wide data storage. I'll say declare instead of define. Let's call it define and allocate. Stores. There's a convention for this. Use m underscore name for these. And these are major. Name of use. Or name and type. Then we have what? Command interfaces. What's this? Incom. Define that's pure data, but define there should be a different convention for this. Command interfaces and dereferences to other system features. It's not good practice though. Example, mincom is, what is mincom? Oh, okay. let's call this define dereferenced. Actually, not dereferenced. These aren't direct handles to returned requested functional system interfaces. Income is the socket object for talking to the Inc. network. Data state. Define and allocate activity interaction state variables. This is different than module-wide data stores. Is more let's call it simulation. This is simulation. These affect simulation. So this might be rolled up with the major module-wide stores thing. Behavior. But it's, I think, good to maintain an idea that there are some properties that are for just module administration, module management. These are used for changing how the simulation works. That's important to know. Data binding interfaces. Like knockout to VM view models. Would be here as well. So then what else do we have here? Scrolling down the screen. Here we're doing initialization. This is system initialization. Initialize the 1401/1701 system. This is usually setting up input modules. Let's say connect. Input models connect to the local app network. This is initializing the HTML layouts with renderer. I'll say that. This is initializing render system dimensions. Picks is that right? This is called initializing the render system. So that's purely setting up. Shorten this init. Load. Init render system. What else needs to be initialized? These are purely system level inits. These aren't simulation inits yet. This is just getting the thing started up. See what else there is. Init input models. Connect to. All right. So then, initialize simulation state for first run. What we're doing here is load external assets, media assets. What else happens? Load additional settings files into global settings object. And that's another best practice thing. Write that down. Right now we have a pretty flexible settings manager, but it's flexible enough that everyone uses it in a different way. So best practices for using settings manager with cascading settings file and cached data. That's not clear to people. Load external media assets, additional settings file object. Load cached state. Let's say cached state from last run of this app. And use if it's valid. And then after that is, I think there's a missing. So load assets is where we're going to do this, load assets, initialize. Does that happen in load assets? Actually, this happens before, I think. Maybe we had to move it. In the construct phase, the goal of this is to, using the settings that are available, can now programmatically create elements. And so what does that mean? That means create all pieces or initialize all data structures for this. What does that really mean? Because there's two elements here. There's one, all the settings are set. So initialize module level objects. Create and initialize module level objects, non-simulation. For the sim side of things, we want to create object simulation objects and put them into groups. Create references to sets of objects. Create tests that operate on sets of objects. What else do we want here? There is something that's in addition to this, we need to define module level message receivers, message handlers for Unisys. Trying to think of. So this is just creating elements that will be used. Then the next phase, start, using the objects created in construct, initialize their behaviors and settings as needed. Let's call that modify their default as needed. After construct, I should note that after construct, all modules should be ready to receive external, to handle public calls. Ready. Request permission from any other module, any other SIM module, by importing it. That should work. I guess during construct, we probably want to have all the handlers set up. Define Unisys handlers. Probably needs to be more than that, but that's basically what happened. And then after this, it's game loop runs next. Or let's just put the whole game loop in here. The game loop is input, update. Let's just look this up to make sure. Where do they define this? In my sysloop module? Connect, initialize, load assets, construct, start, game step. Within game step, we have these. So update, overthink, execute. When does the piece classes get that called? That's something that's a little bit of a not clear to everybody. So game stepping, input, update, think, overthink, execute. Game step starts next. Set modules, overthink. Get inputs from wherever. Make updates to piece properties. Overthink phase. Chance to override any decisions. made during overthink. Executes what do they think it's called on the module level. Let's guess at what to do next. Set flag, control flags, and simulation / pieces. That's something I think is not clear. Difference between think and overthink. Getting tired. It's been about an hour. Just thinking overthink. What's the other change? Oh, the control scheming. Setting intents versus just going and moving something. Yeah, it was what breaks code. Okay, I gotta get a little bit of coffee because I'm about to die. Let's see what I got. I need to buy more of this stuff. I'm gonna have a cup of this Korean coffee. This stuff here. Oops, put a lot too much sugar in that. Here's my hot water bottle, hot water on demand. Very Asian. Hey kitty, you looking better? Seem like in a much better mood now. Yeah, you are, aren't you? Yes? No? He's giving me the stare. Maybe he's not in a good mood.
I don't know.
Maybe he's mad at me. This my old cards. Alright, so we are back. Where was I? So anyways, setting intents versus just going and making something happen. This is unclear too. I'm going to call this the paper of unclarities. Both of these are papers on unclarities. So execute override control flags. This is one reason why I think some of our simulations are unstable. You don't have a good control, a module to help create control schemes. So what the people are doing now is that they're detecting a condition in code and then they're having it change a property directly on a piece. But this creates problems if multiple things are trying to change it. So you need to have some sort of, intent control scheme that this may not be possible to do easily, actually. But you want, the idea is to have something that will record the state that's going to happen. You get one chance to override it. This is the piece level. I don't think players' modules get to think, do they? They shouldn't. Maybe they do still. So in sysloop, if I look at the update all, the connect all, initialize all, load s, no, we don't check. Get input all, physics update, modules update, modules think, modules over, modules do get think, huh? Maybe they shouldn't. So this is in addition to pieces. Pieces update happens separately from modules update. Pieces update first, and then modules update later because it's assumed that they're going to act on the changed pieces. Pieces do not get overthink, though. Overthink is something that, well, pieces get to think, then I guess modules think. And then modules get one more chance to overthink. That's true, because modules may be operating on sets of properties, and another module may modify properties of a piece. So the overthink is a chance to override that. That's still not very clean. So I don't know if that might need some looking at. So the question for that is modules overthink really effective in the multiple players manipulating one piece? Is the stream echoing? I wonder if I create a feedback loop by accident. Does seem to sound though. I don't know what's going on. I have two loopbacks here. What's up with that? If I remove one, it would blow everything up. Open the loopback. Cleaning this up. That's better. Right, back to chat plus desktop. Okay. Where's my other sheet? We go back to this. Interpret command. Can set and think. Overthink. I think in update we're also updating state. Oh wait. I think that's another unclear. That's the difference between properties and state. There's actually a third class of module. Let me make a list of it. Our main execution units are pieces, modules, and then a specialization of that is a player module. All of these are tied into the sysloop system. But then there's also just regular libraries. these are just functional ones. So they don't get the initialize load assets construct start stuff. They just collect code. So what do you call that? I guess these are like just functions. Helpers. Stuff that doesn't need to be phased. Just collects useful data without need for phased startup. That's because they have no dependencies at all. And then there's also a type of module which is more like a data container. Yeah, okay. What am I missing from this? There's another important hierarchy, which is the visuals hierarchy, which is the renderer. Then there's the, what do they call it in 3JS? Objects, graphic objects. Well, visuals. I think they're called object 3Ds in the 3JS library. Or the simple, they have scenes and they have objects. That's what they do. And then they have some utility functions. This is third, so when all of these will get, the game step is outside of this? No, the game step is actually a form of sysloop. Game step, or there's only one instance of that. And the special sysloop manager is the master sysloop maker, and has last say in each phase. So it's kind of so libraries of code goes down here. But don't need phased startup. I don't have phased startup dependencies. And can just run just init immediately. Okay. So, what have I learned from this? This is all startup stuff. So now we need to look specifically. Now, oops, why is this not? Now looking specifically at what's in particles. What are we seeing here? Oh, I put it up. Well, these are the genericized ones. We're going to call this simulation initialize. initialize simulation or initialize playable areas and zones. Can it really do it there? I don't think it's supposed to do it there. Unless it's in settings. Okay. From settings. Let's call these global settings. What else is related to that? In load assets, I said that there was load media assets. In addition to load assets, no, that's right. Nothing much happens in simulation. Load assets. Load media files. Critical to the simulation. To start up. After load assets and during the construct, or simulation construct. Here we're creating the create player or student. Oh, you need a better nomenclature for a player manager. Well, okay, there's going to be piece managers. And then there's pieces. And then there are players. These are students, piece managers. This is code. Students. Create student controlled pieces. Create BC pieces. Create world objects. Set up cameras. And play space. Elements. So in simulation construct, we're creating NPC pieces, create world objects. Then what? There's a part here that's control oriented. Where's the screen manager go? Blink? What was that? Oh, I'm trying to hit the wall. Ow. Somewhere here, there's also user interface. I will make that a separate list of things. GUI initialize, GUI load assets, GUI construct, GUI start. That's one thing that's weird. It's because there's all these different modes that are specific to what you're doing. Module initialize, module load assets, module construct, module start. I'm getting some feedback. Where's that coming from? I wonder if the let me check something. No, it's not.
Wait, what?
I thought I heard like a.
Hot water on the.
It's weird. What happened here? So, hi Kitty. Kitty has come to say hello. So we must say hello back to the kitty. There. You don't smell as bad as you used to. That's good. You in a good mood? No? You want food? NPC world pieces. What else is happening here that's related to that? Create. I guess it's technically part of construct. Create GUI. I gotta put that somewhere else. Let's keep the GUI stuff out of sim. I want this to be purely about simulation. What am I trying to say here? Establish control messages. Handlers. Or do we define our emitters? Control requests. It's not quite what I mean, but scanning, simulation construct. I keep hearing these boopy-loopy noises. Maybe it's just regular sounds. So we define the requesters. I'm just scanning here. Let me just do stuff with GUI initialize. Load base HTML. Create renderers. Load assets. Do new lengthy initialization. Synchronize start of multiple modules as necessary. NECESSARY. Construct. Load default values. State into GUI. What else do you do during this? GUI construct. Oh, set up data binding. GUI start. Enable GUI. Enable GUI responses. So after simulation construct, So we should start. Determine what startup state is required. Configure simulation properties. Props, modes. Enable simulation control messages and emitters. That's one other thing. How to extend Unisys to internal messaging. So then we go into simulation update. All pieces get their update function called. And then simulation think. All pieces get their think function called. I think I can tell. What happened to the test code? When does what's it called? Test factory? What's it called? Referee. Runner. Oh, we're not using it? That's weird to sign here. Oh, I'm getting tired. I'll take a walk later. Just want to finish this train of thought. So, start the function called. My question is, where do you insert the test check? That has to happen after update. Oh, right. That's a test one. Test module run after piece. So put your piece group processing there and module updates. I think that's what it does. At least I hope so. That would be in sysloop. So sysloop is calling all the modules. Update, and this is actually handled in but we can control it. But the master game loot controls the order. Simulation update. All modules then get their update function called live here controlled modules. Only modules have get overthink calls, not players. Consumers. Huh. All right, so that's still an overview. Now let's go now looking. This is what I want. Now looking at specific activities in particles. But I need to take another break. It's been an hour, it's been 90 minutes. It's about the outside of a focused work session. It's like, I guess not too bad. But I need to take a break of some kind. So I am going to do that, and I'll be back for part 3. What time is it now? It's been only about an hour, actually. It was like we're getting all set up beforehand. It's 2:21, so I will call this 2:15. Resume architecture breakdown 13 or 14:15. So what's my billables up for today? An hour and a half. So I have another. If I can get another 2 hours in today, that would be good. I think I'm slowly forcing myself into organizing the thoughts here, and I have a list of questions of things that probably need to be resolved or clarified for everybody. But this looking at specific activities in particles, that's going to be the actual interactive story part of things. So it'll be seen in day 1. These systems are used by kids. And I think that's where I'll get a sense of what the lower level interactive elements are going to be. And since I already know that there are pieces and there's a world and so forth, but I don't know really what properties and how they're handling no, I'm blanking on stuff. Well, I think I'm going to take a nap. I feel like really drained, sloughing through this stuff. Okay, I'll be back a little bit later. Hope your work's going better than mine. This isn't bad, actually. This is just pushing through and forcing myself to remember things. And then I can hopefully make something that's a concise reference that will help everyone move faster in the future. And, most and more importantly, be able to build these interactives faster. That's really the holy grail here. All right, so talk to you later. Oops, I didn't close this.